All right, draw a mapping diagram of the ordered pair shown. So our mapping diagram is made up of two ovals. One oval is going to have my x coordinates in it, and the other oval is going to have my y coordinates. So my x's are 3, 5, 7, 11, 13. My y coordinates 17, 19, 19 again, we only list it once, 23, 29. Then I draw arrows to represent how they're related. So 3 goes to 17, 5 goes to 19, 7 goes to 19, 11 goes to 23, and 13 goes to 29. All right, which gives us C. Now, the second part of this question says, is this a function? Well, to be a function, all right, you can't have an x cannot be mapped to two different y values. All right, so if you had two arrows coming out of an x, then that is not a function. All right, so we don't have that case here. So this is a function. And then there's two types of function. There's one-to-one, and then there's a many-to-one. Okay, our example is many-to-one because 3 and 8 are both paired with 7. So that's where you get many-to-one. That's still a function. All right, for the linear function f of x equals mx plus b, we're told that f of -6 equals 16 and f of 9 equals -14. And then the question says find m and b. All right, well, what function notation means? This here tells us that an x of 6 gives you a y value of 16. And this one tells you that an x value of 9 gives a y value of -14. Okay, now this is the equation. This is a linear equation here. And m is the slope. So our slope equation is y2 minus y1 over x2 minus x1. The b represents the y-intercept. So I'm going to do my slope first. So I'm just going to call, let's say this one x2, or excuse me, y2, x2, and this one x1, y1. So I will have -14 minus 16 divided by 9 minus -6. So that gives me -30 over 15. So when I simplify that, I'm going to get -2. All right, so now I know my m, my slope is -2. So I'm going to take out m and replace it with -2. Okay, and now I want to find b. So remember, f of x, guys, is the same thing as the coordinate y. So I'm going to take that out and replace it with a y. And now what I'm going to do is I'm going to substitute one of the coordinates of one of these points. So I can substitute -6, 16 or 9, -14. It doesn't matter. I'm going to use -6, 16. Okay, so negative 16 is my y, negative 6 is my x. So this would become 16 equals negative 2 times negative 6. And now I can solve this for b. So my m value was negative 2 and my b value was 4. Okay, find the domain and the range of this function. So our domain refers to all the possible x coordinates. Okay, so looking at our drawing here, the smallest x coordinate, and we go from left to right here, would be negative 4, and it's included in that graph because there's a closed circle there. Then the graph continues forever in the positive x direction because this is going to keep going down. So my x coordinates are going to keep getting bigger and bigger. So I can say that my domain is going to be include negative 4 and then extend forever to the right, and that would be written as positive infinity. Come on back here. So this would be positive infinity. All right, my y coordinate or my range is going to be from the lowest y value up to the highest y value. Well, this graph continues forever. So my lowest y value, there isn't one, it's negative infinity, and this graph would extend up to the y value 4. So my range is going to be from negative infinity, that's with a parenthesis, up to and including 4. And that's our domain and range. And below it are some of the notes that we did that are in that function. Okay, you're given this function, and then you're told f of 2 is 7. So this is telling us that the point 2, 7 is on the graph. Find the value of a. So what you do is you plug 2, 7 in for x and y. Remember, f of x is the same as y. So I'm going to take out f of x, replace it with 7, and then each occurrence of x I'm going to replace with 2. And solve this now for the variable a. All right, our next question asks us to find the value of a. So what you'll do is you'll substitute in 2 is your x coordinate. So every place where you have an x, you're going to substitute in the value of 2. And then where you have an f of x, that's the same thing as y. So I'm going to substitute 7 in for that y value. our equation will look like this once we do the substitutions. And then we're going to work this out, collect our like terms, and then solve for A. And then once I go ahead and multiply this out, collect up my like terms, solve for A, we get A is -5. So this problem just comes down to a matter of substituting in and recognizing that this notation right here, when you see this, this is telling you an X coordinate, and this is the Y coordinate that goes with it. And then you can substitute those back into the equation so that you get an equation with only one unknown in it, and then you can solve that unknown. Okay, number 5 is asking you to evaluate, this is a composite function. So what we're doing is when we have a composite, what that means is that we're going to insert g of x into f of x. That's what a composite function does. Okay. Our notation means you are inserting the function g of x into f of x. All right, so what all that means is that when we see an x here, we're going to put in its place the expression 2 minus 3x, and then simplify it. So f of g equals square root. Now, in place of that x, I'm going to put in g. So that will become 2 minus 3x. And then I copy the rest of this, which is just going to be minus 6. And then simplify that. I have 2, and I got -3, or excuse me, this would be 2 minus 6, which would be -4. So -4 minus 3x. That is my composite. All right, now to find the domain of that. So on our domain, we have these are the only situations you've got to worry about domain. And in this example, you have a value under a square root. So this expression here has to be greater than or equal to 0. Otherwise, you can't do a square root. So to find the domain of this, we're going to take the radicand, which is -4 minus 3x, and set it greater than or equal to 0, and then solve that. So we add 4, and we end up with -3x is greater than or equal to 4. Then I'm going to divide by -3, which means I have to flip the inequality. I get x is less than or equal to 4/3. So any value that is less than, or I'm recording this, sorry. Any value that is less than 4/3 works. So that means from -infinity up to 4/3 and including 4/3 because of that equal sign, then that would serve as your domain. So on this page here, I put the other notes on domains, on how you find them, as well as some examples from the notes that we took during that time. So the one that we just did would have been similar to this example right here. Okay, for number 6, there's 3 questions. The first one, okay, G of F. So that tells us that we're going to put F into G. F into G, whatever the second function is. Okay, so our G function is 3x plus 13. Howdy. And I'm going to take out that x, and in its place, I'm going to put f of x, which is x squared minus 3. So that's going to equal 3 times x squared minus 3 plus 13. And then we just simplify that. 3x squared minus 9 plus 13, which is 3x squared minus 9 plus 13 is positive 4. And that's my composite function. All right, now to do the composite of, to then evaluate these, well, you did the composite, it's right here. So all I've got to do for this next part is substitute x into my equation that I found here. So I'm going to go 3x squared plus 4, that's my composite. And in the place of the 3, I'm going to put, or in the place of the x, I'm going to replace it with 3. So that's 3 squared plus 4. So that's 27 plus 4, which gives me 31. Right, and then on the final one, G of F negative 2, it's the same thing. I'm going to take my composite, and in the place of the x, I'm going to put negative 2. So I get 3 negative 2 squared plus 4 plus 4 plus 4 is 16. Howdy.